Good afternoon. Welcoming everyone to the largest solar energy technology focused event for ASEAN region, that is Solar Project Engineering Week 2021. It's a two-day virtual conference. In the next 2 days, we will be having insightful discussions focusing on engineering, design, and construction of solar projects. Session experts will also discuss the current and evolving technology trends prevailing in the industry and how it impacts the procurement of equipment for the projects. Discussions will also focus on latest hybridization techniques of renewable energy projects and engineering challenges associated with them. I would like to thank our sponsor, Silver Partners Core Energy, for joining us today. With this, let's begin with our first remarks on latest solar EPC trends by Mr. Bamapada Jatak, who is a senior VP expert from APAC and IGMA from Juvi Renewables Energies Private Limited. Over to you, sir. You'll have to unmute yourself.
Yeah, sorry. Thanks, Sagita. Thanks, Nikita, for giving me this opportunity. I would like to tell everyone that good afternoon and thank you very much. So I would like to tell Nikita that Nikita, could you please start the presentation in your screen?
Yes, sir. We'll be sharing in a minute.
Yeah. So quick introductions. My name is Bamapada Jatak and I'm working GE Renewables sitting office in Singapore, and we are working here last 3 years, and here I've joined GE Renewables almost 3 years back, and I was heading engineering APEC, and presently I'm working as a senior PV expert, APEC and EMEA, both the regions. And here, basically, we are here as a EPC player and project developer team. So we are developing project in Australia, in few areas. We are trying to develop in Vietnam, and that 2020 for everyone are very vast, and then we did only almost 200 megawatt of projects here, and next few years we are going to develop almost 1 gigawatt of projects. So here just I would like to tell few things, few very brief, the EPC is brief and what we are doing here exactly, and what are the challenges and what would be the future deep cost and the LCOE. So next slide. Yeah. So here just I'll give the overview, that is the engineering overview, the business model, that is how engineering is coming from one to another, and then the feasibility studies, and then the plant, the most challenging theme with this engineering, that is 25 years life, plant life, design and constructing, that is the other balance of system, that the quality, how we ensure the quality for 25 years life, plant life, and present, the bankable, the solar projects, what would be the risk and how investors are looking for the entire plant scenario. So next. So it's an engineering overview, like the policy wise still it is government policies and discount policies driven business. If you see Vietnam and Philippines and even in Australia, the entire petal films is a government driven, but still the project developers are looking projects for the particular tariff and film. So there is the open access and called a direct connections. And another is the business model. So earlier, 10 years back, the project capacity was only 5 megawatt, 10 megawatt, 20 megawatts. But now most of these projects are 50 megawatt and above. So we need to understand this one, technology selections and the civil engineering and structure related selection. So these are the things, and we need to discuss, and we have to give our insights on that. and then we'll take all of your insights on that, and then we may proceed further. So Nikita, can you continue it, or others participate also can give, and then again I will start, or how we will do?
Sir, you can finish off your presentation, or is your presentation done? Then we can proceed ahead with the panel discussion if it's done.
Okay, good. So then I'm continuing it here. That the feasibility reports. Here actually the EPC contractor has to do the concept to commissioning. So here the concept, whenever project inquiry would come, we're seeing the project, how project it is, and then the project's capacities, what would be the locations, and the generation, the radiation based, the PVC generation, and of this perspective, contour, and etc. So there is a feasibility studies here. After concept, all this conceptualization, the feasibility studies, and this feasibility studies, actually we need to understand the entire philosophy of our business, that okay, these things are there, like let's say the first after feasibility studies, that there would be the technology selection. Let's say what would be the project size, what would be the albedo, how we will select the materials, that means the technology selections. Here the most important part is the generation. So and of course the capital investment. So here the capital investment is not only the depending upon the site, it is depending upon the perspective, the grid perspective, the DISCOM, what DISCOM needs. So grid codes is there. We need to understand the grid codes of this, and the preliminary design, like the module technology, the inverter technology, the structure technology. So here, let's say the site is a high wind zone, so we will not select the single axis tracking system. We will not select the single axis tracking system. Then we would not go to the module selection, the bifacial module, because whenever bifacial module come into the picture, we have to use the single axis tracking system, because the entire Southeast Asian region, the tilt angle is very minimum. So minimum tilt angle bifacial module doesn't make sense. So this part is more important, the feasibility study, and then detailed engineering study. So detailed engineering study will provide the entire concept, entire inputs of design inputs, like the civil perspective, like soil frictional rules, grid studies, like grid values, fault level, everything you will get through the grid studies. And then the safety point of view, you need to check the lightning issues is there or not. You have to check the plant contour, and based on the contour you need to check the technology again. So a lot of things are there, like the AC/DC ratios, like the wind factor, like everything would come up after the detailed engineering studies. So here again, the design perspective, here we have a K1, K2, K3 for wind speed, local wind speed. Most of this developer, they are mentioning now the K1, K2, K3 is a one constant, but it is over design. If you will change it to, let's say K2 is a lesser than one, like 0.85 or 0.9, then entire wind speed and all these things would be different, So then it is entirely different about the risk against the capital cost. So we need to check the better options on that, and we have a lot of tools like design optimization tools, and based on the design optimization tools we need to provide the solution. So besides that, the project sites, the inverter technology, they are now it would come the string technology or the central inverters, string inverter or central inverter. So if the contour, let's say it's a highly undulated land, so always better to go, if it is 50 megawatt or less, always better we have to go with the string inverters, because of some generation loss or mismatch loss. So again, it is absolutely, it is depending upon the capital cost and the generation, how much generation we need to we will get it, and how much generation, what would be the capital cost. So besides that, could you please come next slide? Yeah, so when we'll get everything, everything done, and it is that it is the cost matching and all these things have been done, so then it would come to the development phase. And after this development phase, the detailed design phase would be there, and most of this time the structures design by our structure manufacturer, and we need to check that all this prospect, that what would be the tail size, what would be the deflection, what it should be L5, L180, or L160, what would be the model withstand capacity based on the structures, because most of the time it is very critical for any wind zone. Besides that, then the construction phase and then O&M phase. So just quickly overview I'm giving. I'm not giving very detailing. If you have questions, you can ask me. So next slide. Nikita, next slide. Here, the feasibility studies is the first. Actually, we need to check the environmental impact, because most of the time we are not seeing the trees and all these things. We're not checking that what would be the environmental impact, the entire environmental impact. Techno-commercial feasibility studies also is required for within this feasibility studies. Local government regulations. I will give a very simple example. We have done 50 megawatt project in Vietnam, Cat Hip, the evacuated Cat Hip substation there. And this 50 megawatt project, when we started, it is the EPC. GE has done the EPC. When we got the order that time, even in another region, Neng Thuan project also, you can see that there is no boundary road. So when we started the project, at that time nothing was there. So when we submitted for fire regulation approval, so they told that no, we need the boundary road, and the fire regulation boundary road is very expensive. If we do the boundary road, it is very expensive. So we have done it, but we need to check. That is the reason actually I gave this point, that we need to check the local government regulations, site detail studies with the local conditions. So this is the most important part. Detailed engineering studies, including civil. Civil means you know better than me, I think. So let's say the local wind speed and standard, and what would be the soil test, the ERT test, the soil frictional test, pocketing, and then the electrical test, the grid studies, grid impact studies, like a load flow studies, like a flash level studies, like a short circuit plane studies. So all these studies are required, to optimize our equipment. Mechanical also and communication also is required here, that how I will communicate. Let's say if we'll have a two flip locations, one I need to update, I need to upload to the cloud my entire plant information. So then it's a one channel, another channel. Grid has to take the input, and grid has to provide the input for the plant required capacities. So we should have the RTU panel for that. So this one also is required. Energy yield projection. So we have a PVCs now 7.1. So we are using this PVCs, and you can use PVCs or PV for this generation projections. Financial summaries also is there, that based on the optimum design and the generation and the BOM capital cost, you have to take care of this. Risk analysis and mitigation plan also is there, that what would be the risk. So as of now, I have seen that here in Singapore region, there is a huge risk on the lightning and all this. But in Vietnam region, lightning risk is very less, but still we have the risk, and we need to plan that how it will mitigate. So risk assessment for lightning, IC 62305 part 2, the risk assessment also is required for few locations. Engineering, procurement, construction schedule also is very important for these studies, and O&M requirement for the power. Manpower requirement also is there because the cost involved is there. Next, Nikita. So complete feasibility studies at the risk. We have 2 or 3 documents here. So okay, so I got Vietnam risk. A lot of questions are there, but I will give it to you later. You can ask me. In Vietnam there is it is absolutely I got one questions from there, that the risk, in Linthorn project there is a little bit lightning risk, and soil erosion risk also is there. Soil erosion and flooding risk also is there. So we need to check the locations, and based on that. So this is the studies, the risk, So it is the risk here. In 2 organizations, TUV Reland and European Insurance Company. So they have done some studies in this region, and they got ultimately the information, and decided that most of this, almost 50%, 40 to 50% is the wrong installations. And I will give all these documents later.
So what we can do is we can take up the questions later after the panel, because the panelists are also waiting. So as of now, you can proceed with your PPT.
Sure, thank you. So here is the wrong installation, wrong design, flood, fire, and others. So, and defect for the performance. If you see the documents, this documents actually the most of this plant in Southeast Asia are not working well. And many projects, actually, not most of this, many projects, some of this project I can say, the performance ratio and generation are not very good. That is because of the few issues like installation issues, maybe design engineering issues, like product defect issues or maintenance. So these are the things. And Nikita, could you please next slide? Yeah. So entire industries actually are getting pressure. Entire industries are getting pressure on this, like what would be the generation and what would be the quality 25 years life of this plant. So you can see that the feed-in tariff is getting reduced every month, I can say every quarter or every year, whenever it is moving. So Japan's feed-in tariff and this Southeast Asia's feed-in tariff is reduced, So again, I think it would come first. Vietnam told that okay, we will go with 9 cents and then 7.5 cents and then 7 cents. Now I do not know, 6 cents or something. So probably April or March end or April, again it would come. So entire pressure is coming to EPC or engineering, but not like we need to reduce the cutoff from our POM or from the inferior qualities or like this. No, we can generate a lot of we can see the generation part as well. So generation part, if we will go with the generation part and we'll check the option is there, so then we may proceed further. So here first thing is the selection of the material. So if it is let's say that the components, whatever the local conditions has to withstand, like if it is let's say if it is some flooding type areas or something, we need to use the 87 or marine type cables. If it is highly corroded area or corrosion, so C5 we have to use for structures, for other equipment, something like that I'd like to tell. So if it is let's say the high fault level, so we need to check it and we need to provide the similar isolator or breaker or whatever is requirement. So component, so here component standard like IC and UL standard has to be used, and local standard need to be checked for each and every equipment. Component test report, and we need to check the each and every components, quality at site, at manufacturing unit and site, and analysis the component failures from previous project. That's also, it's very important for us. Nikita, next. So again, this one is the cost, and like maintaining the balance between the performance and the cost. So again, we have n numbers of tools, with us, and we are checking every time that what would be the best generation, what would be the minimum equipment cost. So here the MMS design, again, as I explained earlier, that the local wind speed, based on that we need to check the structure, we need to check based on the structure, we need to check the module technology. So foundation, again, the foundation, and there is most of this developer, they are saying that first, 8 years back or something, that we need the good drainage system and road. So in my opinion, my last 15 years of experience, and that the most of this plant where you have a good soil bearing capacities and there is no runoff water phase, so it's very minimum drainage system is required. And whenever water or higher rain came, so automatically this water could be evacuated with the main water stream. So these things are most important. And technology selections, as I told, that it is absolutely depending upon the site. It's the albedo, soil reflection, wind speed, and the structure, whatever we do. The inverter technology also, it is absolutely depending upon the contour, is absolutely depending upon which technology you are using, local conditions, ACDC's ratios, what is the radiations, and SCADA also. Block monitoring is enough if it is in Southeast Asia. If it is in Australia, so then manpower cost is very high there, so then string monitoring makes sense. So system monitoring requirement also is depending upon the requirement on the particular locations, and of course the investors requirement. Yeah. Next, Nikita. Yeah. So here the bankability would come, then evaluating the technology, and all investors like us, whoever will invest money on this solar project, definitely they will ask the risk, and we are also lead the risk and all this. It's required actually. The commissioning schedule and the operation and maintenance details also is required. So here the end of this PPTs, I would like to tell that the entire risk and entire claim is depending upon the design and design perspective. It has to be clear to the investors and stakeholders that the present scenario, we need to check all these points, and then we can make decisions on this.
Thank
Next,
you so much.
I think it is okay. Yeah. Thanks, guys. Now you can ask questions.
Thank you so much, sir, for the valuable insights. So what we will do is we will take up the questions after the panel discussion.
Sure.
Thank you. Attendees, with this, we will be proceeding with few polls. So here comes the first poll for you. Do you think ASEAN region will be able to achieve its target of 23% RE in the region's energy mix by 2025? I'm closing the poll now. 64% of attendees agree with it. Thank you, attendees. Here comes your second poll. ASEAN is becoming a renewable energy hub with increased deployment, innovation, and investments. I'm closing the poll now. Well, that's a positive sign. 67% of people agree with it, and 33% of people strongly agree with it. Thank you, attendees. With this, we will be proceeding ahead with our panel discussion. The topic of panel discussion is going to be solar project engineering, procurement, design, and construction management. Session experts who have joined us today are Mr. K.K. Kong, who is a managing director from Macro Engineering SDN VHD, who will also be session moderator for today. Mr. T.S. Izwan Rasool, who is a technical manager from Leader Energy Private Limited. Mr. Song Sak, who is a senior vice president, construction management from Impact Solar Group. Mr. Chris Vincent Aridon, who is the head of project business from Sol Energy. Mr. Federico Bestiani, who is a director from BEC Limited, and Mr. Bamapada Jatak, who is a senior VP expert from Jubi Renewables Energy Private Limited. I would like to hand over the session to Mr. Kong to take the discussions forward with other speakers. Thank you. So you'll have to unmute yourself.
Hi, good afternoon, everyone. My name is Kong, K-O-N-G Kong, and thank you for Nikita and Sanjita inviting us here today. And it's a lovely, very shiny afternoon in Malaysia here. I'm from Malaysia, and we have quite a good mix of distinguished speakers and panelists here with tons of experience that they are willing to share. I hope you guys will enjoy the session. And without further ado, let me a brief introduction about myself. Our companies are based in Malaysia, and we specialize in consulting works in Malaysia related to solar farm and rooftop solar. And here they are, other than myself, there are 1, 2, 3, 4, 5, five very distinguished persons that are very experienced in the field of solar energy. Number one, I'd like to introduce probably they are Mr. Izwan. Maybe you can raise your hand. Okay, Leader Energy, which have quite a numbers of owning a few solar farm themselves. And number two, the panelists from Thailand, which is Mr. Songsat. Hi. And they also have a portfolio of vast experience that later they will share. Mr. Chris from Sol Energy, Philippines. Hi, Chris. How are you today? Yeah, and all these are from Southeast Asia. And we have a very distinguished guest, Federico, which is from Italy. Vienna, a lovely city. Welcome. Look forward for your sharing later from BEC. So of course, you know Mr. Bamapada that have
Hi,
shared some very detailed, insightful information about engineering aspect of the solar farm construction from development to O&M. Okay. We will zoom in and dive in more detail shortly. Okay, and he's very active in APAC. Has been running around Australia, based in Singapore, Vietnam market, and so on. Okay, so Allow me to start with the. I would like to structure the panel discussion into eight sections from the very beginning of the project engineering design up to the project logistics and so on and so forth. So, as for project engineering and design, may I ask the panelists what is your feel or your experience that how important is this prelim design or engineering design that will determine the success or the failure of the entire, sometimes this project can last from half a year to, for big scale project, probably 1.5 years. Okay. So can anyone volunteer to share about this?
Hi, KK.
Yeah, Federico.
Oh, I saw Federico here.
Okay, I will thank you for the introduction, and yeah, I can reply regarding the rooftop solar projects, and I would say that the approach that was shared before by Mr. Bamapada is perfect, even for the rooftop solar projects, because even the project size is smaller, usually is between 1 megawatt and 5 megawatts in Vietnam, by making several groups of 1 megawatt projects. The approach that we need to follow is exactly the same. So we need to consider a lot about the local regulation, especially about the firefighting regulation, because it can sometimes undermine the whole project, since if you choose the wrong project and you don't make enough checks at early stages, you can have some incurred cost in the middle of the project that can make the whole investment completely unprofitable. And when we are talking about some firefighting regulations, there is no way you can save or go around that one. So the way to structure the early stage study is never enough time to do. The more time is spent on that phase, even for rooftop project, the most profitable is the project execution. So I would say this phase for a rooftop, it can take from 1 to 3 months. And the most important things to check is the first is the legal documentation about the ownership status of the land or the factory, because sometimes the factory belong to a third party, like the industrial park, and there is some rent contract or lease contract with a certain duration that must be checked very carefully with the help of a local legal team. After that, we have the civil and structural requirements, since many factories they look very suitable for install the megawatt scale rooftop, but when making a thorough structural study, some of these factories do not meet the requirement of the construction law. So at the moment of installing the solar asset on that, it can create many problems and many additional costs to renovate the structure of the factories, and finishing with the firefighting studies and the grid studies, because even the rooftop is a smaller project. In the last year, it has experienced a very big boom in Vietnam. So some areas are already congested, by rooftop projects, and the utility is not ready to take all the power, especially in the weekends or during the holidays. So need to use the same approach that use with the solar farm project, also for the industrial scale rooftop.
Okay, Federico, can you probably share which market are you active in, and a brief introduction of your company? Probably all speakers should do that.
For the past 3 years, we have been concentrating in Vietnam, which it was the highest growing market. So we took this bet 3 years ago, where it was very pioneering, but the market proved to be a successful one, because in the last year alone there were commissioned almost 10 gigawatt of projects. It was a very exponential growth. So we had a lot of experience in this market. So all my comments are for the industrial rooftop in Vietnam.
I see. Okay. So thank you for your insightful sharing. One of the things that has been highlighted extra is that is very gratefully appreciated is the legal aspects of the land rights, and the rooftop rights. That is very helpful for all the participants. Probably everybody can take note of that. Okay, and number 2, the feasibility studies. Okay, in the aspect of feasibility studies, for probably Mr. Chris and Izwan can share some of your experience in your region, Philippines or Malaysia, how to craft and decide and filter and choose projects from the perspective of how important this is, the feasibility studies. Maybe Chris first, then followed by Izwan.
Hi, KK. Good afternoon to everyone as well present in this conference. And thank you for inviting me.
Maybe a 1-minute introduction of your companies.
Okay. Yeah, very short introduction. I'm Chris. Sol Energy is a company primarily focused in the Philippines. For the past 9 years in the rooftop space, we've done about 40 megawatts of rooftop. We're building 5.2 megawatts right now. And also utility. So we've done approximately 100 plus megawatts of utility and building 60 megawatts right now, and supporting an 80 megawatt project. So we're quite across the whole market segment, even the off-grid section. Just to quickly answer KK, from a very limited perspective of the Philippines and our company, a lot of how and what is essential in a feasibility study has been discussed earlier by Mr. Mr. Bamapada. He gave a good discussion of what a good feasibility study is. Maybe what I'll just do is then describe how that is now happening inside the Philippines. So a lot of developers in the Philippines, IPP developers, they have their own processes for them to make or to decide if a project is feasible or not. And what they have found out is that there is I don't know if it's a huge cost, but it's definitely a cost associated with conducting these feasibility studies. So they can range from anywhere between $60,000 to $200,000 US, some even more, right? And for these entities, who are very conservative and have very limited capital, one thing that they responded to that is how they responded to that is they have been a bit averse and quite choosy in which projects they conduct feasibility studies on. What we have done as Sol Energy for them to be able to hurdle that, meaning for them to be able to conduct the feasibility study, is we enter into what we call an early works agreement with the developer. So if the whole contract of the feasibility study is, let's say, $50,000 US, what we tell the developer is, let's conduct that progressively. We will give you information that's meaningful to you at a time that you need it. Like, for example, initial capacity, initial generation, and then it goes up until all the risks associated with the project and the intensive detailed design. But what we tell them is that, okay, pay us a nominal amount. It can be 10%, 20% of that feasibility contract. And then if the project goes into a successful financial close, ready to build, then if you award it to us, we'll waive that amount. So you share the risk with us. If not, then we can come to some sort of arrangement where that cost is either reduced or paid back to us if you decide to give it to someone else. So what that enables these developers to do, and we've had 2 projects that have been successful under that scheme, is it enables them to go into developing a project with a strong technical partner without having to take on a huge amount of cost. There have been challenges associated with that, like how does that play out in a bid, but that's something that we've also managed to do as well, and I can describe that further.
Okay, cool. So that thanks, Chris, for sharing on this concept of giving them a smaller entry price, to them to develop more projects, for EPC to have jobs, for engineers to have jobs. Very good, very good. So how about Izwan, your experience sharing for Malaysia type of solar farm development?
Hi, thank you, KK. Good afternoon, everyone. Okay.
Introduce your company.
Okay, my name is Izwan. I'm from Leader Solar Energy. We currently own and operate 2 large-scale solar farms up north in Malaysia. And moving forward down the pipeline, we are venturing into the solar rooftop market by offering power purchase agreement to potential clients moving forward. Okay, coming to your point with regards on feasibility studies, from our standpoint, I can actually break it into 2 components. One is technical, one is financials. When I look into a technical, it can be done via a desktop study, or if you go to do a thorough site visit at the potential client's premises. Okay, by doing a desktop study, you are able to actually identify the capacity that can be fit into the particular premises. Okay, and then although of course it's still regulated with our Malaysian regulations, whether the area is subjected to a high fault rate and so on and so forth. Okay, not to go really into detail, with that particular capacity, we are able to actually forecast our generation. Okay, with that generation, we should be able to somehow rather relate to EPC costs and how much the return would be on our side. We also, it's still subjective to the premises technical study, as what Federico highlighted also, that after a while you found out that the factory structural is not sound. So things like that are supposed to also take into consideration. Okay, then it comes to the financial part of it, whether the particular off-taker is financially sound to actually undertake of such project although small scale or large scale. This is from a PPA point of view, because it's going to be a long-term business relationship between us and the off-taker. So this is some of the points where we can mitigate the risk. Also, how does it relate with regards to after construction, performance, and cost? Just to share one thing is the location of the inverters on where it is located at the off-taker's premises also plays a big role, just to actually, for example, if you install an inverters in an enclosed room, it is subjected to derating factors and so on and so forth. That could affect performance and your revenue down the road. Just sharing one example there. Yeah.
So that's quite insightful. So every small single decision making and that will help to contribute more generation for the investors. That is very good. So, and allow me to move on to another subtopic, which is the key elements of infrastructure planning. Okay, and I understand that Mr. Songsak from Impact Solar Generating Thailand, they have a massive experience, more than 93 mega of rooftop PPA, and in the pipeline, and 45 mega already in operation. Can you share about yourself and your company and about these topics? The key element of infrastructure planning. We can't hear you. Can anyone hear Songsak?
No, no, KK.
Yeah, same here.
I think he muted. Could you please unmute, Mr. Songsak?
So we aren't able to hear you, Mr. Songsak. I think there is a connectivity issue at your end. Requesting you to kindly rejoin again if possible.
Oh, okay. While we wait for Mr. Songsak to solve the challenges, okay, some technical challenge, probably I can move on to Pamapada. Can you elaborate some of the things that pop up in your mind related to this civil and structures engineering planning topic?
Yeah, so a lot of questions also are coming here that I'm giving. I'm trying to give some answers, but yes, the civil and foundation related for projects. Let's say it's the ground mounted projects and the rooftop projects. So rooftop is concerned. It is entirely depending upon the which type of roof it is, and we need to check that roof's sufficient models and structure bearing capacities, and it's a slanted roof, it's a simple flat roof, concrete flat roof, or it is let's say it is a metal ring roof. So again, it is absolutely, it is depending upon the site's ring roofs, and the gap between the roof and module also is required for air passing, and a lot of things are there that need to be checked. Besides that, as I explained in my presentations earlier, that it is absolutely depending upon the client, you know, or the IPPs, which model they are looking for. So one part is the structure, another part is the technical part, and grid injection part, that net metering is there or grid is there or something. So civil is concerned, yes, it is for the tapering, roof, foundation, loading, and local speed, and ground mounting also. It's a contour, flames, soil, flames, and the foundation again.
What kind of experience sharing that you can share with the audience, that what to be careful, especially on the civil portions for solar farm? This question is open to all that have the experience. My experience is when we did our 50 megawatts in Gambang, in one of the states in Malaysia, and the soil condition is in the same piece of area, but the soil condition of different zoning is so different. So we have to adapt using different piling, some span pile, concrete pile, and some screw pile, and different type of combinations. So, and that will impact the costing also. And if we did not enough this Macintosh or whatever sort of soil test and borehole testing, you see, that will also impact. In fact, we have one challenge that we have done the soil test at this zone, and the adjacent is so different, and it will impact the project timeline. So if there are choices, please do advise the developer to spend more monies on having more sampling points of the
of course, yes. Yes, it is actually so
so I guess a lot of our guys have this experience before, right?
Yeah. So this is the main criteria. If you see, for 40 to 45% cost to be borne by solar PV modules, but the civil and foundation stuff, structure, that is also it's a major part. Is the 20 to 22% or 25% cost would come, the entire foundation, civils, roads, drainage system, and all these civil structures and all these things. So this is very good questions, that how we will do the engineering aspect. Like let's say our total capacity is 50 megawatt projects or 100 megawatt projects. So total 100 megawatt project means it is approximately, let's say, 300 acres land, or I can say, let's say 250 hectares of land. So 250 hectares of land is used, and generally project developers and consultants are doing that. Okay, you give me the soil test report. So they are giving the pocketing soil test report, let's say 10 numbers pocketing report, and you will get it. You will get it. The soil fractional values, soil ERT values, and all these things like this. And what they are doing, they are saying that whatever the worst condition they are taking, and they are giving the solutions. Now you can see how much risk developers are taking. So let's say if the worst soil condition says that the piling, let's say the piling depth is, worst condition is 3 meters because of some 10 holes, wherever they have done, these 10 holes are in the black cotton soil. Let's say, assume that like this. So 3 meters, but after that, when you will do all this design, but actually only the 4 square meter area is 4 square kilometer area is like this, or let's say only 10 hectare or 20 hectare area is like this, but rest of this are fine soil. So that means only 1.5 meter. So that means it is a huge over design on that. So here, suppose if I will do again that the 10 holes, it's a 1.5 meter of depth, then again it would be the risk, for the developer. So we need at least, I think this is my practical experience, that every hectare you have to do at least, or every 2 hectare you have to do at least 1 holes. So you will get a more insight on that, and you will get more information from the soil, and you can make a decision. So here, what KK is saying, that somewhere else is the concrete piling, somewhere else is the ramming, somewhere else is screw piling. I can say that I do not know who has done your design, entire design, but whoever has done this design, he used to try, I think he would try to make the highest optimum level. So here also is the huge optimization opportunity. Suppose if we have, let's say, 100 hectares of land, 100 hectares, what generally consultant and designers are doing, they are checking the lot of holes and the whatever the worst condition of the soil, they are doing the design and then they are spread it the entire. So here I have seen that 5% or even 2 to 5% are over designed the entire project cost. So if we will do like this, like where, you know, if we can divide the block, let's say in one block, let's say 5 or 6 zone, and every zone we can make it that, okay, this piling would be like this piling would be like this, and properly planned if we'll do, then definitely developer can save a lot of money on that.
Yes. Agree. So the take home today is probably anyone have other design ideas? Now we are saying 2 hectares, at least one soil test report. 2 hectares, at least one, right? So
Yeah.
anybody else? Mr. Songsap, is your audio coming back? Hello? We can't hear you. No sound. Now it's mute and unmute, but we cannot hear you. So okay, let's we have another like 15 minutes. So the next topic will be quite interesting because it's more on the project's technologies, the about products, the technologies that we choose, the quality, the life, kind of stuff. So probably Mr. Federico, can you share with what are some of the newest updates in terms of the technologies that's happening that we should be aware of, and your experience on that also. And
Thank you very much.
After that, probably a 5 minutes thingy, and anyone wants to share, top up, feel free to do that.
Okay, I will tell you the experience that our company had in the past 2-3 years in Vietnam and in the Southeast Asian market regarding the technology for the industrial rooftop systems. So we saw, starting from the inverter, the most maybe the most important change is that up to 4 years ago, we could really see on the rooftop maybe a mix use, some project use the single MPPT inverters, and some project use the multi MPPT inverters. For example, before since our company is Italian, we work a lot with the ABB inverter and SMA in the past. But what I've seen in the last 2-3 years is definitely a spread of string inverters with multi MPPT. So maximum 2 strings for 1 MPPT. And this is I can understand this tendency of the market because the installation of these inverters is much easier, and it is much more difficult to make mistake for the installation team, since these inverters they don't have any combiner box, and they don't have any fuse design, so it's really difficult to make a mistake in connecting the strings. So we have seen like a big spread of like major producer of inverters like Huawei, Sangro, Solis, that are pushing this technology successfully, that has gained a lot of success here in Vietnam. Basically, everyone now is using these inverters to install the rooftops. The cost also has decreased a lot. So this is the first tendency that we saw. Another one is about the solar panels. So starting from last year, we saw a great dominance of the mono solar panels instead of poly for the rooftop projects. Since I see that the cost difference between poly and mono is not as big as before, and in our experience, in our system, we see for the rooftop a great advantage in using the mono panels, especially the half-cut cell, since so we have, for example, two projects next to each other. One project is using full cell poly, and the project next door is using half cell mono, and the temperature of the solar panel is completely different. So the half cell mono is about 6 to 10 degrees cooler, and this is a very important factor for the rooftop, because in the rooftop you cannot modify the tilt of the panels. You need to follow the roof most of the times, especially if you are installing on a metal roof. So you don't have a lot of chances to reduce the temperature of your module. So if you choose the module that by design it can have a lower operating temperature, it can bring a lot of advantage during the operations.
I see. Thank you so much. Probably I can do a quick check for everyone. Currently, you can mention a quick answer for solar farm. What kind of DC-AC ratio that you are adopting? It can be a range. And for rooftop, what kind of DC-AC ratio? Anyone?
I can take up that answer.
Okay.
Okay, it depends on your design and what would you like to achieve. For a solar farm, of course, you would definitely like to have an optimum highest output during the peak generation hours. So I could say a ratio of between 1.4 to 1.5 DC to AC ratio.
Okay.
For solar farm. And then rooftop, it is still subjected to location as well, depending on the specific yield, irradiation, and stuff. So, for example, in Malaysia, up north, 1.3 to 1.4 is still a good ratio up north. But maybe down south, 1.4 to 1.5 could be still an optimum ratio to actually have that optimum level of production during the peak hours.
So Mr. Izwan is about 1.4, 1.5. How about Philippines, Thailand, Vietnam? Chris, your site will design with what ratio usually for your customer?
Sorry, KK, can you repeat that? Just that last thing
usually you design your solar farm or rooftop at what ratio for your clients?
In the Philippines right now, we design it for rooftop between 1.2 to 1.35, I think was the highest we ever did. Okay. For ground mount, we do 1.5, just because, I mean, it's more of the nature of the competitive environment. A higher DC-AC ratio drives down the cost of the plant. So it's more driven by that, I guess.
I see. Good.
So KK, I would like to tell you that the AC/DC ratios it is absolutely, it is depending upon the radiations level, and the other is the export to the grid. So in Australia, let's say AC is the inverter capacities you are talking about, and the DC ratio is the total DC capacities of the modules. So here in Australia, they are saying that the export to the grid, let's say my total inverter capacity is 40 megawatt, and my DC capacity is, let's say, 50 megawatt peak, and then my grid, I can inject maximum to the grid is 30 megawatt. So they are considering that whatever the injecting power to the grid, it is the capacity of the entire plant. So based on their grid export, even if you see the PVCs itself is available, that what would be the one is the inverter capacity, another is the grid export. So there is the grid export, that maximum how much you can do, and based on that you will select. Yeah. So here one is how much clipping loss you are considering, that what would be the clipping loss of inverters, and what would be the what is the acceptable for you, like let's say we have a design optimization tools, let's say 5 inverters I'm giving, 5 inverters 2 megawatts, so total 10 megawatts of AC capacities, and this 10 megawatt, if I'll go with the 12 megawatt, then my generation is reduced, my generation is increased, that is because of the lesser clipping loss. So 10 megawatt inverter, suppose my clipping loss is 2.5%, and 12 megawatt my clipping loss is let's say 0.5%, and this 2% I'm gaining, and this 2% with the feed-in tariff, it is okay. So then I can increase my inverters, and then I will make the decision. So the decision making process is like this: what would be the generation increased, and what would be my capital investment decreased, and based on that, if I'm checking that okay, my LCOE is coming with the 12 inverter, I have to make with the 12 inverter with the DC-AC ratios, and if it is coming to no, if the capital investment is higher, then I will go with the 10 inverters. So it is absolutely depending upon the how we are modeling, how you are doing my business, and how it is IRR and everything. Yeah.
Hey,
how I'm
that
getting
is
the LC.
very good sharing from Bapak Badam. It's a very dive in and in-depth of explaining the design mechanism and taking into the cost and generation to an optimum balance point. Thank you very much. I hope the audience.
Songsak, sir.
Hi, did you hear me? Did you hear me? Hi.
Yes, Sang. Yeah, good.
I'm sorry, I have technical problem about the setting of the microphone, no? But now it's okay. It's okay for you, right?
Yeah, please introduce yourself and your company. And
okay. Hi,
yeah.
everyone. My name is Songsak. No, I'm working with the Impact Solar Group, and we are the developer and build, own, and operate the plant by ourselves. We have more than 93 megawatts right now, and we do the private PPA. We are the first private PPA developer in Thailand. So please let me share the issue about the KK asked me about the key element of infrastructure. No, from my past experience, when we developed the one of our big customer in Thailand, is it the super center in Thailand? At that time, we have more than let's say 42 locations, and we have to do the size around 500 up to 1 megawatt, and we have we have to do the site inspection first before we perform the construction. I can separate the issue into two parts: the civil part and the electrical part. For the electrical part, at first we have to do the laptop study of the off-taker load profile to ensure that the off-taker load profile is enough and matching with our install capacity or not. And another one is the location of the inverter room. We try to select as close as the existing MDB as much as possible to reduce the loss of the cable And also the connection point need to check the existing system. Is it necessary to be upgrade the circuit breaker or not? Or we should connect at the low voltage or high voltage. It's subject to the cost of the developer as well. But we have to compare between them, that which one is better for us. And also for the civil part, we have to inspect the loop and the type of the construction and installation. Is it clipping tie or drilling tie? If drilling tie, we have to check about the bone and nut condition. Maybe we need to replace all of them. And the clipping tie, we have to check to ensure that we can install as much as possible for the install capacity. And do we need to upgrade or replace the skylight, the metal sheet? Some part is already damaged. Then we need to repair before we do the construction. And also the loop structure calculation, we also need to verify that the drawing, the existing drawing is in line with the site condition or not. If not, then we have to check whether it need to be do the reinforcement or not. Yes, that is. And also another part like the existing walkway, existing site ladder, everything need to be prepared to for the long term of the project lifetime. Yes, that's
I
it.
see. So how many teams do you deploy over 2 years period to execute 42 locations?
Actually, it's only one main subcontractor, but they hire another 4 team for the subcontractor level.
I see.
The project is divided into 2 phases, but the time is left between each of them. But we can complete it within 2-year construction.
Wow, very good. I mean, you only deal with one main contractor, and they settle everything for you. Congratulations.
Thank you.
Very smart project management. Okay. Talking about that, the next topic will be, we have another 15 minutes to finish off 2 topics, and then we go to Q&A and try to answer the questions. So the participants, you're welcome to blast your question in the Q&A section, not the chat section. So the panelists can feel free to take their questions and answer by typing, or later you can also go through one more round verbally. Feel free to do that. My panelists, thank you very much for helping on that. And
sir, what we can do is you can take up the questions one by one and address it to the speakers.
Okay, cool. Let me settle last 2 topics. One is the selection of the right partners. Okay, every one of us here is players in the industry. So sometimes you go to other countries to do projects, you know. So if in your home country, how do you select your partners? And if you go overseas to do projects, you know, how do you select your partners? Okay. Who want to share some insights, you know, for our peers here?
So I will just give my insights here, because we are working in different countries always, you know. Sometimes Philippines, Thailand. We have office in Philippines, Thailand, Vietnam, Australia. So local subcontractor finalization is a huge task, because we need to understand this subcontractor is capable to do the project. This is the first thing. And second is that the subcontractor should have enough technical and commercial and financial capability. And third thing is that the subcontractors are able to do this work with whatever the local regulation subcontractor knows or not. That is also the question. So we have our standard format, and subcontractor has to fill it up and give some introductions and interview or something, and then we can select it to the subcontractor. Besides that, the subcontractor credentials also is there, that how many projects they have done in the particular region, and the subcontractors manpower, and how many engineers and how many like technical and non-technical peoples are there, and how they are executing philosophy, and they're all this flipped and they are planned. You can understand if you talk to any subcontractor that this subcontractor is capable to do it or not.
Okay, that covers most of the things. Anyone want to add some of your experience that that you should take note of while selecting your partners? Maybe not only the construction, so the O&M portions, O&M usually you all do in-house or outsource?
I can take that question up.
This one, yes. You are farm owner.
O&M, basically we do it in-house.
Okay.
Because the priority to actually fix the matter with the lowest downtime, that plays a very crucial factors. Also, coming to the point with the AC and DC ratio, for example, if we have one inverter that goes down or breaks down, the other remaining inverter can still meet the particular generation target on a daily basis. That's another thing. And then also educating our personnel with latest technology, for example, drone imagery flying on the power plant just to actually mitigate any flaws coming from the PV panel. For example, hotspots, diode burns, crack of panels, any strings which are in an open circuit condition and stuff. Things like this, it's very crucial when it comes to a solar power plant. In fact, in a rooftop as well. So if, for example, you have an outsourced O&M, it's somehow or other, it's like a chicken and egg situation, whether you actually rely, or are they doing as per our requirements? Do they have the right experience, the knowledge, the skill set and stuff? The reason why we do it in-house is we can get it done as fast and efficient as possible, and by hiring the right skill set who has O&M experience moving forward.
That is for the view from Izwan, Malaysia. And I believe there another school of thoughts. Anyone want to share that the farm owners should hire, so the question is, should they do it themselves, hire the full-time expert teams to do the O&M, or outsource to professional O&M players that are focused in.
Please let me share my idea. When we do the operate and monitoring the plant, we also do the same as Iswan mentioned, that we do by ourselves. We do monitoring by ourselves, and then we hire the subcontractor to do the corrective and preventive maintenance. And that the reason why to do that is we can immediately respond to the issue, and we can command to the subcontractor to correct the issue immediately. When we found the issue happen in the site, then they will go immediately to the site. Yes, it's better in view of the owner.
How about Chris? I guess if we are the speakers, if we are the farm owners, like from the perspective of Songtap and Izwan, which is farm owner or rooftop owners, when they have that skill, the the owners will hire the professional teams to manage, of course, it's our own asset, which is reasonable. So from the perspective of Marco, myself, or Chris, we would very much like to have this kind of business segment there. Someone engage us to manage their rooftop or their farms, with a contract of 3 years or things like that. Chris, your side, do you manage any plans, for your clients?
Yeah, we do. We're managing one utility farm right now, one large rooftop, and also when we finish the 60 megawatts, we will be the operations and maintenance company as well. And what we do as a strategy is during the construction phase, we already hire the operations and maintenance engineers. So this way they get familiar with the whole construction process. They know like the plant inside and out. So that's something that's familiar to them. And during the operations and maintenance phase, they get retained at the plant to operate it. Yeah,
I see.
So that's our
Usually, usually in our experience is the financier, the bankers will want the new project developer or farm owners to immediately sign a contract
yes,
to reputable and experienced O&M operators. Maybe it's the same EPCs, so that to make the whole projects bankable. So after the third year, something like that, maybe the owners will take over back. So that are the usual experience that we are facing with our clients also. So I think Papa Padam have Pama Padam. I think your side also have so many EPC contracts, and plus to some of them engage you for O&M services after that. Federico is in the business of you are owning the PPA.
So we are the EPC contractor. So yeah, most of the time we are selected as O&M companies. So we need to check the monitoring of the plant and give the weekly report to the investor, or some other times, like Mr. Songsak said, investor, they have their own monitoring facilities, so they have their staff that daily monitor the plant, and when they find some strange behavior of the plant, they send a notice to our team that they will go on site to check, and if needed, replace or fix some parts. So it depends on the structure that the investor have. Some investor they like to outsource the O&M part. Some investor they like to keep the monitoring in house.
Cool. Okay.
Yeah. Okay. So right. Thanks. Thanks, Purit and KK. So just I will give 1 minute, one insights here, that as we are doing many EPCs, like what Purit is saying, we are here we are giving the product warranty and guarantee. So if we will give the EPC contractor for operation and maintenance, so let's say I'm giving the performance ratio guarantee or performance ratio guarantee or product guarantee for, let's say, for few years, and it is depending upon the maintenance. If you don't maintain properly, then it will be the problem. Then it could be the void, the guarantee void. So I would suggest for our developer that whoever is doing the EPC, this EPC contractor should do the operation and maintenance. That makes sense actually. It is a single point responsibilities, and and you will not, you will not feel that, okay, there is a risk, So that is the reason always better to give the operation and maintenance whoever done the EPC. Yeah, thank you.
Thank you very much. So there are two school of thoughts. One is do it yourself, and the other one is pay someone to do it. Okay, it's your own choice. Okay, so yeah, we have another 3 minutes before we should end the panel session and to pick up the Q&A questions. So 3 minutes. So everyone, 1 minute to share your experience about supply chain, project logistics. Did you face issue like me? A 40-footer container go through villages, it cannot turn, or it's stuck some wires or tree, issues. So the logistic planning is very, very important also to meet the project timeline. Anyone want to share? So my experience is we faced some challenges before of entering to the site that is very far away from the main road.
I can share some, KK.
Yeah, please.
So yeah, I was involved in a wind farm feasibility study that even at the FESIB, we already considered the logistics. So even to the point of identifying if there were box culverts, and if there were bridges, what was the tonnage capacity of the bridges. So those things already get considered at the onset, because like you said, the logistics it will be a big part of the success of the project. Just very quickly, another story I can share is we had a problem right now, especially with the COVID, right? With the pandemic. A lot of our suppliers and partners reduced their operations. In particular, in the Philippines, we had a partner that was supposed to deliver us a critical component for the steel structure of the substation. Because of that, because of the pandemic, they reduced their labor by 60% and not able to deliver on their commitment. So it's one of those things where we needed to take the manufacturing in-house. So it was good because we had a sister company that had CNC laser cutting machines. So we did the whole steel structure ourselves. And moving forward, I think that will be the direction for us to vertically integrate as an EPC on the critical path items like these items.
I see. Cool. Yeah, very, very important to check every single thing along the path that will either save you money or cost you more money. Anyone else? So you can take one more comment.
I can just share just a little bit funny. Basically, we had this was 3 years ago, where basically we had a mounting structure shipment to arrive at site. The moment everything was unloaded and the moment we actually look at the box to start installing our mounting structures, the roof hook that they gave was the wrong one. So, and it's from China. So there you go. So it affects the whole project entire timeline. But good enough, we have a local supplier that really had the correct number of stocks. So somehow or other, our life was saved in a way.
Good. Okay, thank you very much for some, that is part of the topic. We are all engineers here, and the topic is sharing of, it's very kind of for the panelists to share some experience, to our peers here. And I hope everyone has enjoyed this, Sangeeta and Nikita. So thank you for the opportunity here. And how do we do this? The next session.
So you can take up the Q&A. We have got 4 questions in Q&A box.
Okay.
So if you could take up those, thank you.
So the first one from Adrian D. Adrian D is sounds like Indonesian or Philippines. So hi, good evening. Good afternoon. So the question is, oh, okay. Mama Padam, maybe you can take this up.
Yeah. So the questions actually I have seen, but I was typing, but it was not synchronized with this. So that is the reason. The question is that what would be the, I believe I can remember the, but here I'm not seeing here because all questions and answer are deleted here now. Because
Kong sir, what you can
yeah.
do is you can read up the question and
Oh,
then you can pass it out to the session.
If you guys can't see, let me read it out again. So, how much nowadays average tariff price for each?
Yeah, tariff price. Yes, tariff price and battery system is enabled or not. Just 1 minute. Just 1 minute because 4 o'clock. Sorry guys. So here I would like to address this. Yes. So here the tariff actually what the questions this questions is she wants to understand the tariff. So this tariff actually depending upon two parameter. One parameter is the capital cost and another is the generation. So unless I do not know the locations, it is very difficult to understand the generation. So suppose let's say the Vietnam areas where you can get the specific productions, let's say 1500 kilowatt hour per meter square per 50 per kilowatt hour per kilowatt peak per year. That specific production you will get even 1800 or even 2200. So this specific production is absolutely depending upon the solar radiation, and the tariff also depending upon this. So that means your generation would come from 100% to 60%. So it is very difficult to say that the tariff would be like this. So if somebody would give the proper locations, or let's say average location, so I can provide that. Okay, this is the locations, this is the wind speed, this is the bill of material average cost, and this is the generation. So 25 years if you will take, and another thing also is there, which IRR you have to take. So suppose you are taking that okay, I'm taking loan with 7% or 6%, and I'm looking for 30% or 12% IRR, then also your tariff would change. So you need to check that what would be the location. You need to check that what IRR you are looking for. Then only we can tell that okay, the tariff would come like this.
Okay, probably.
Can we have the views of? Can we have the views of other speakers also on the same question?
I guess this is a very customized and
can we have the
question that probably the attendees can ask privately to Ramapada on this, because it's really depending on the location and all this. There's no one simple answer for this. So
yeah, there is no straightforward answer that I will tell that it is a 20 cent or 10 cent or 5 cent. There is no straightforward answer, because if I'll say 5 cent, if I'll say, let's say 5 cent based on what? Based on my radiation, based on my generation, based on what is your IRR, everything are linked with this, right? Even I need to understand the entire thing, then only it is possible. Otherwise no. And storage system is concerned, battery is concerned, storage system, that is also is depending upon the which time it is, because now most of these locations, let's say in Vietnam, EVN, they are trying to give from next year probably the feed-in tariff with a different time zone. So the time zone, which time zone you are talking about, and the battery system, whatever she has mentioned there, that battery system would work like a voltage ride through or like a frequency ride through, because let's say I have a system and this system would start, this is a hybrid system, let's say solar PV modules, batteries, and my gas turbine. This is the future combination actually, because solar only connecting to the grid. it doesn't make much sense, because I cannot reduce my carbon, I cannot reduce my generation like this. Like, let's say my boiler is there, my conventional power plant is there, it will not reduce it. So the battery system also, when I storage that, what would be the peak tariff and how we will accommodate the peak tariff? That is also the another question. Or the battery I'm using for what purpose? The solar is not there. So, yeah. So that is also is very important.
Thank you. Probably you can attend. I can recommend the person that asked this question attend because First View Media also have some events on energy storage. That would be a very good platform for you to ask these kind of questions.
Yeah. Yeah.
So I like to take these interesting questions as in how to avoid leakages if we need to be penetrating the MMS to thin sheet purlin. So MMS, I guess, is the
model mounting structure. I understood this question. So this question is how will leakage? Leakage means is trying to say that the leakage is there. You know, most of this EPC contractor, they are. So two things are there. One is the star bolts. Star bolts is there. You can directly connect to there to the earthing, or you can provide the continuous earthing slips there, and you can use it. So
can we have the views of other speakers also? Sir, you can address the questions to other speakers as well. The same question that Bamapada sir has answered. We can have views of other speakers also on the same question.
So I can reply to this one since I need to leave soon. I can give my feedback on this one since we had these issues in the past. So for maybe who raised this question is EPC dealing with the corrugated sheet roof. So that one is a very tricky roof. You need to be very extra careful when installing on the corrugated sheet roof, because it requires you to make several roof penetration, and this is not doesn't mean that whenever you make penetration you will make a leakage, but usually the factory owner is very sensitive about when the EPC company is making penetration on the roof. So they will very likely pick up any existing roof leakage that they have and charge it on the last person who is doing the job, which is the EPC that is installing the solar. So you need to first be very careful in the preparation phase. You need to do a leakage test. So if it is the rainy season, we always go under the roof during the big rain and see if there is any existing leakage, and we notify with the client. If it's not the rainy season, you can invest a little bit in a water with the water nozzle and bring some water to the roof and spray evenly, which some stuff is staying inside the factory and recording any existing leakage. This is very important because once you start working on the roof, no matter if the leakage is there before or not, if you don't record it in advance, it will be your fault anyway. Then it's going to be your problem in the future.
Thank you.
That being said, when you use a penetrating screw on the purlin, you need to be very careful on the L-fit installation. So you need to be very clear with the subcontractor, with the workers, what is the waterproofing and the installation part. So spend extra time on installing the L-fit and have a very thorough check before installing the rest of the mounting structure, especially before installing the panels, because once you install the panels, it's impossible to see any mistake that the installation team has done. So you need to proceed very slowly, step by step, and if you do like this, you will avoid and you will be successful in installing on this roof.
Okay.
So
good. Yeah.
Thank you very much. now I need to join another call, and thank you very much for having me in this panel. Looking forward to chat more with you. If you have any more questions, you can send to my email address here.
Okay, thank you, Federico. Yeah, he needs to excuse himself. So
thank you so much, sir, for the valuable insights. We will surely keep you posted with future events. Thank you very much for joining us. Over to you, Kong, sir.
Yeah,
Thank
one
you.
last questions from the attendees is what the EPC idea about independent monitoring system? I like to pose this question to Songsa, because you have so many rooftop that you are monitoring your own. So what kind of do you have your own independent software, or how does it work?
Actually, we buy the software from the one of the well-known company in America. Actually, I can say the name. It is also Energy.
Okay.
And then we try to use and manage the software to check the performance and capacity factor of each plant to manage and control the O&M contractor to do and respond as soon as possible to monitor the performance ratio and clean the PV as necessary to keep the capacity factor in the rate that we fix it.
I see.
Yeah.
How about other than the software? How about the weather stations? Do you have any irradiance sensors?
Yes, we have. We also buy it in the same package with the monitoring system. Actually, we use CRIP and Sonan, which is I think the best one in the world.
Yeah, I mean, it's the premium brand. Yeah.
Yes.
Okay. I see.
The issue we always found is sometimes we install so many loop in the same area, but we have only one pyranometer, something like that, and then we have to calculate the performance by using only one.
Improvise.
Yes, correct.
So it's always a balance between the cost to spend and the accuracy of the monitoring. So
correct.
it is quite difficult to convince the owners to invest more. You see, usually it's for compliance. In Malaysia, Izwan, correct me if I'm wrong. In Malaysia, every 10 mega need to have one weather stations. So if you are doing 50 mega, so you only need to invest 5 weather stations. Okay, so it's actually not really good to cover.
But it's not good. It's not good for the financial.
Yeah.
I can agree with you on that. Yeah, KK.
So actually, for engineers, for us, the more the merrier. So the data more accurate, but it will be more costly.
But financial team may kill you.
Yeah. So maybe you
Thanks, guys.
Yeah.
I'm leaving now. I have another meeting. So thank you very much, all of you. Sorry. So Nikita and Sangeeta, I'm leaving now.
Thank you so much, Bamapada sir, for your valuable insights. We will keep you surely posted with future events. Thank you so much for joining us.
Thank you, sure. Thank you.
Thank you.
Thank you.
So I guess I've covered all the relevant questions. The rest probably need to take up in other type of areas. And so I guess we are done here. Anyone have any more ad hoc things to add or questions from the audience?
Sir, I think we have taken up all the questions which we had received from the attendees. So can we have the closing remarks from each of the speakers before we conclude the session for today?
From Chris?
Hi, yes, closing remarks. thank you for inviting me. And yeah, I think I'll just point back to the sentiment of the first two questions in the poll of this webinar. Is there is a growth in the region for solar and renewables in general, and hoping to capture that and hoping to at some point partner with you guys or meet you in person. Thank you.
Okay, Izwan?
Would just like to say thank you for the opportunity, and it is great to meet a few more fellow friends around Asia. So yes, like what Chris indicated, yeah, looking forward to maybe working together, maybe in the region one day, hopefully.
Yes. So, Mr. Songsa, close some remarks.
Thank you everybody for thank you for the organizer and KK to invite me to join this event. It's good to speak with your team, no? And for the audience. I hope that solar energy is already proven and everybody should involve in this market. It's better for everyone. Thank you.
Yes. Thank you, Sagita and Nikita, for inviting us here. And let's together we help to grow the renewable energy, solar, wind, and others renewable energies in the region. Let's make Southeast Asia the growth area. Let's create more jobs, for more engineers. This is Solar Project Engineering Weeks, for ASEAN. Thank you for spearheading this on first view of having us. So hope everyone has enjoyed and benefited from our panel discussion just now, and look forward to see everyone again soon in other events and some more physical meetings, you see. So look forward to have some more physical events here in future organized by First View, be it in Malaysia, Thailand, Philippines, or wherever, that we can meet face to face with the panelists and also the participants.
Thank you all the key panelists for your valuable insights. Thank you so much for joining us today. Attendees, please do join us tomorrow for the second day of Solar Project Engineering Week. Please note, we would be having sessions starting tomorrow at 4 p.m. Singapore Standard Time, and the sessions would be focusing on RE hybridization along with insightful presentations. Attendees, see you tomorrow. Thank you so much.
Thank you. Bye.
Thank you. Bye. Thank you.
Bye. Thanks.